Okay, this is the NPV and IRR part of capital budgeting. These are actually much better numbers to work with as far as decision making. The reason is we're actually considering the time value of money here, and that the dollar, that everything we did before this back in the ARR and the payback is ignoring the fact that the money we're going to get paid back 4 years from now is not the same as the money today because of the time value of money. So here's what I did to make you an example. If someone offers you $1,000 today or $1,000 in 1 year, what would you do? And of course you would take the $1,000 today because you wouldn't want to wait a year. But what if someone says you could take $980 today or $1,000 in a year? Well, now you have to make a decision. Is it worth waiting a year to get the extra $20? That's a decision. What if they offer you $900 or today or $1,000 in a year? Well, now will you wait a year to get the $100? What if this were $500 today? What if you take $500 today or $1,000 in a year? Would you wait a year to double your money? So the time value of money does matter. It's not all the same thing. Okay, so now we're going to do it. Let me just show you how these numbers are put together. So these are this is what I'm doing is I'm saying we're going to get $1,000 in a year no matter what. We're going to wait 1 year for $1,000. The question is, the chapter 12 question is, what is the most we would pay today for that $1,000 we're going to get in a year? I'll say it again because that's a critical question. What's the most you would pay today for that $1,000 you're going to get at the end of year 1? And it all depends on what interest rate you want to earn. If you want a low interest rate, you'd put in more money. You just put 971 today. If you want to try this on a calculator, try 971 times 1.03, you'll get $1,000. There's a rounding issue because these are all rounded numbers, but it'd be close to $1,000. If you want a higher interest rate, if you want to go up to 8%, you're going to put in way less because you need 8% on your money. So put in 926 times 1.08, you'd have $1,000. Notice that the higher the interest rate, the less you're willing to put in. If you want 15% on your money, you're going to put in way less today. Okay, look at the bottom half of page 8 then, and this is the present value table you're going to get to do the homework. These are built in as to all the accounting problem, all the MyLab problems. And then the way it'll look is, let's just say you're going to get $10,000 the end of year 1. It's 10% that you're given. This is what you're given. This is the data. And then you look up year 1. Year 1's the top. 10% is 0.909 right there, 0.909. So 0.909, 10% is, and then you multiply those two times each other, and then that's the most you'd be willing to pay today. If you want to test that, I'm just multiplying that by times 1.10. I'm raising it by 10% for that 1 year, and I'll be right back at my $10,000. There's a rounding issue, of course. If it's year 5, then I'm just going to be paying less. So if I have to wait 5 years to get my 10%, and I have to wait 5 years to get my $10,000, and I want 10%, then I'm only going to pay 0.621. So that's see that 0.621, that's where I'm getting it from the table, 0.621. So what that's telling me is I would do, that's just how much I would have at the end of year 1. And then I would just keep going, and at the end of year 5, I will have $10,000. So if I get that today, and I accrue 10% of my money per year, at the end of year 5, I will get my $10,000, and I will have earned my 10%. So the question is, what's the most you would pay today? I would pay $62.10 today. If I pay $62.10 today, and you give me back $10,000 at the end of year 5, I will have earned 10%. Here's the proof. All right, I could do a million more of these, but I think you get the idea. I could keep plugging in numbers all day, but that's how you use the table. Look for the year, and you look for the interest rate. If you want to test that out yourself, just pick a year, pick an interest rate, give it a try. Try 3 years and 8%, and just you get this 0.794. And if you want to see if that works, just take whatever you got times 1.08, and then just do that for a couple more years, and you should get back to your $10,000. So just try that over and over. So I'm raising that by 8%, so you see what I did. I just took it by 8%, and I just kept doing that, and I'll get my 10,000. That means at most I would pay $79.40 today. I'd pay, and then if I get 10,000 at the end of year 3, I will have earned my 10%. So that my 8%. Okay, moving along to annuity table. This is the next thing on your in your Word document is the annuity table. It looks really complicated when you first look at it. It's actually should make sense in a couple minutes. What this I'm telling you here is that there's something for the word annuity has a lot of meanings in finance. For purposes of chapter 12, the word annuity just means the same cash flow every year. Same flow every year, $1,000 a year, every year. And in the problems, it could be 8 years, 10 years, 12 years, and these numbers could be really big. It doesn't matter. It's just the same amount every year. And the way we would do it is if we were doing it the slow way, we'd say, well, the most I'd pay for this year 1 is $909. We just figured that out a minute ago. And the most I'd pay for this one is this. And so if I want to buy the whole series, I want to buy all 5 of these together, I would pay the sum of all of this together. I would pay $37.90 for because I'm buying 5 different future cash flows. I'm buying 5 different $1,000 amounts in different time periods. And so I'll pay $37.90 just to kind of keep you in reality. I'm getting $5,000. For that $5,000, discounting them all back one at a time, I'll pay $37.90 for that $5,000. That's what it's telling me. I'll pay $37.90. There is a faster way to do that so that I don't have to do 5 different calculations or 10 different calculations. Rather than doing that, I could just add up all the factors together and just multiply it by one factor and get the same answer. There's a rounding issue here. But this is essentially the exact same number. If I weren't rounding anything, it would have been identical. So let's try some different amounts. Let's just say I put in $10,000 as the future value, and let's say our hurdle rate is going to be 8%. What that means is I would pay $92.60 for this 10,000 all the way down. I'd only pay $68.10 for the 10,000 at the end of year 5. If I add all of these together, I would pay $39,930. Remember, I'm getting $50,000. So for that $50,000, I'm willing to pay $39,930. If I do that, I will have earned my 8%. And I'm proving it. If you want to really prove it, you'd have to multiply this times 1.08, this times 1.08 twice, and so on. This times 1.08 5 times. All those would come back to the 10,000. And it would all grow to $50,000 and prove that I've earned exactly 8%. So $39.30 is the present value. It is the most I would pay. I would pay up to $39,000 for this $50,000 if I want to earn 8%. The faster way to do that, so you don't have to do all these calculations, is to go to the table. 8%, 5 years is 3.993. You put the 3.993, multiply it by the 10,000, and you get your answer in one calculation rather than all this. That's a lot of extra work. So that's how that works. You just see the number of years the annuity will be going on, find the percent interest rate you want, and multiply it by that factor. And if you want to always have a reality check, add it together. Like do the 10,000 times 5, because then you know you're talking about $50,000. And so that 50,000, then 39 makes sense. If it's 100,000, that would probably be, if that was 100,000, so that'd be 20,000 a year. So 20,000, I'd pay 79,000. And then the higher the interest rate, the less I'd pay. So for that 100,000, the 20,000 times 5, that's $100,000. I want 18% of my money. I would pay $62,000 for that $100,000. So it looks goofy when you see 20 and 62, but it's really not 20, it's 100. So I'm paying 62 for the 100. So I hope that makes sense. That might help you understand it a little better. Okay, so I moved on to page 10 on the handout. So now I'm on the net present value. So here's the big question. If we pay the asking price for this investment, will we reach our hurdle rate? That's what the NPV is asking. If NPV is greater than 0, we invest. If NPV is less than 0, we do not invest. So here's a really simple example. We have a 40,000 investment, 7,000 for 8 years. The residual value is 8%, and the interest rate is 10%. The way we do it with the tables, so I'm going to go back to use I'll jump to the tables when I need them. So the initial outflow, we call that year 0 because it's happening today. We don't discount that in any way. So the initial investment is just the initial investment. We're putting out $40,000 today. We are going to get $7,000 back for 8 years. So we're getting $56,000 back. The annuity question is, what's the most we pay for this $56,000? So you take the $7,000, you go to I have the tables in here. So you go to the annuity table. I forgot the interest rate, I'm sorry. It was 10% for 8 years. So you go to 10% for 8 years. I see it's 5.335. So I take that 5.335, multiply it by $7,000. So I would pay $37,345 for that $56,000. So that's the most I paid for the annuity. This also has a residual value. So at the end of year 8, it's worth something. It's worth $8,000 at the end. I will pay for that. I will invest because I'm going to get something out of that. So at the end of year 8, I will get $8,000. So now I'm going to go back to this table, not the annuity table, but the regular table. And I'm going to go, it was 8 years. I forgot what the percent was again, but I think it was 10%, 0.467, is it? Yeah, 8 years, 10% is 0.467. So that's 37.36. That means for the $8,000, I will pay up to 37.36 for that $8,000. I'll pay 37.345 for that 56,000. I'll pay 37.36 for the 8,000. By the way, that's the 56,000. That's the 8,000. So I pay up to that much. It turns out NPV is positive. The reason that is happening is because I would have paid that plus that. I would have paid $41,000 for this investment and still gotten my 10%. At $41,000, I would have earned 10%, but it's only asking for 40. That's actually a deal. That means I'm doing better than 10%. I beat the 10%. I would have paid more, which means it's doing better than 10%. So the fact that NPV is positive tells me I beat my hurdle rate and I will invest. So the answer is yes, I will invest. And the reason is because I beat my hurdle rate. So the answer is yes. And the most I would pay to answer the bottom, the answer is, I just answered it basically. And the most I would pay is 41,081. That's the answer to this question. So the answer why is because I beat the hurdle rate. That's the why. I beat the hurdle rate. Yes, I beat the hurdle rate. The most I pay, 41,081. All right, if you want to stop and try, feel free to pause the video and try a couple on your own. The present value tables you'll need are above. The annuity table is on page 9. The present value table is on page 8. So feel free to use those tables and see if you can get Project A and Project B. So I'm just going to pause for a second, see if you want to give that a try without me. Okay, I'm coming back. If you did it Project A, maybe you're just watching me do it and you're not pausing, but either way, I'm just going to show it to you. So the initial outflow is year 0, so we're putting out $100,000 today. The annuity itself is 6 years at $22,000. That's $132,000. So the question is, what's the most I would pay for that? So I go to the annuity table from page, I think it's page 9, the annuity table, and look at 10%, 6 years, and I'll see that the factor is 4.355, and that's $95,000. So for that $132,000, I will pay $95,000. And then for the residual inflow was $15,000 at the end of year 6. I go back to page 8. That's the factor. So the most I would pay for that $15,000 is $8,400. So I pay $9,500 for the annuity. I pay $8,400 for the residual value. So the most I would pay for this investment is this plus this. That's the most I pay, $104. I can tell you right now it's looking good. The fact it's only asking $100 and I would pay $104 means that I beat it. So the net present value is positive. That's a good thing. If this is positive, the answer is yes. So I will invest because I beat my hurdle rate, NPV is positive, and I would actually pay $42.70 more than the asking price. So I would pay $104,270. That's what this is telling us. That's a much better way to measure something than those things we did back with payback and accounting rate of return. Those really don't consider the time value of money, but this does. Project B. I'll just open it for you. Hopefully you gave it a try. If not, I'm just showing it to you. It's the same $132,000. I'd only pay. The only difference here is that there's no salvage value, and since there's no salvage value, the most I'd pay for the investment is $95,000. It's asking $100. The most I'd pay is this plus this. So the most I'd pay is $95. It's asking $100. The NPV is less than 0. When NPV is negative, we reject. So I would reject this offer, and I would, because we are not earning 10%. And the most I would pay to answer that question is $95,810. That's the most I'd pay. I would not pay $100,000 because that would be more than I wouldn't get my 10% if I did that. Okay, saving the best for last, we move to the last page of the handout, which is internal rate of return. This really is the best measure of all because it tells us our actual rate of return considering the time value of money. Remember the ARR we did, accounting rate of return, much earlier in video 1. That acts as if the 10,000 we get in year 8 is the same as the 10,000 today. And we know now that that's not true. So an internal rate of return considers all that discounting and gives you the true rate of return considering all of that. So I'm going to show you how the theory of it first. So I'm just going to use project A from a minute ago. We just did this. Project A was $42.70 and we decided yes, we would invest. We decided the most we would pay was more and that we beat our hurdle rate because the NPV is positive. We must have earned more than 10%. We decided that. And so now I'm on the exact same data. It's the $42.70. I know I beat the 10%. So I'm just going to show you just what internal rate of return is really doing. It's guessing, trying to figure out the exact, exact rate of return. So we know it's better than 10%. So I'm just going to do some trial and error to show you 12%. Notice, just keep an eye on this number, by the way. I'll just make it yellow so you see it. Keep an eye on that yellow number if you can see. I don't know, that yellow is not very bright, but hopefully you're seeing it. So it's in 12%, it went negative. So then, therefore, we know we did not earn 12. 11, it's still positive. So we did better than 11. 11.5, it's negative. So we didn't do that well. 11.4, still negative. 11.3, now it's positive. So it's between 11.3 and 11.4. I could do this all day long. I'm getting close. So that's about the internal rate of return. As you can imagine, there's a much smarter way to do this. They wouldn't expect you to go back and forth, but it's also not a formula you can do quickly. Excel can do it for us. I'm showing you what Excel would do, or what you would do if you were using Excel, is you'd put in year 0 first, and then each year has to go in individually. Excel doesn't understand annuity, so you have to put each year in individually. And in year 6, you have to add together both the annuity, the 22 plus the 15, because you got two things happening in year 6, and you can't put them on two different rows. Excel doesn't understand two different rows. It'll think it's year 6 and year 7. It doesn't understand you're combining two things for year 6. So it's just year 0 and forward. And then to get it, you would just do equals IRR. and then just kind of select all the cells in the exact order of the years, and it would tell you the answer. It's 11.35. Remember, notice how I was almost there? So it's 11.35%. That means that's the true rate of return we're earning on this investment. And now we can make a decision. Is this worth investing in at 11.3%? It's such a better measure than the ARR. ARR is good for quick, and rough, and if you're just doing something that's simple and not too expensive, the ARR is fine. But if you're actually investing an extensive amount of money, you really want to look at the internal rate of return, considering how long it's going to take to get your money back. So that's what it measures. Okay, and then for the homework problems, what they're going to do, just to keep it simple, since all you have are present value tables, they're always going to give the IRR questions to you where there's no salvage. So there's just the annuity. Right now, all we know is that was negative. It's less than 10%. We don't know what it is. They're going to ask you sort of the range of what it is. The way to get there is you really just want this to be 100,000, because if 100,000 is the most you pay, and you're going to pay 100,000, then your NPV is 0. So all you do is you take the initial investment, you divide it by the annuity. I just did minus because it was already negative, and you divide it by the annuity. That's the factor you need. You need a factor of 4.545. If you paid 100,000, if you pay 100,000 for that 132, you would have you'd be exactly at 0, which means that's the exact interest rate you'd need. So then you go to the table and look to see if you can get that exact interest rate where 4.545 is the factor. It's 6 years. I'm going across row 6. I'm seeing that there's no 4.545, but it's more than the 8%. It's more than 8% and less than 10%. It's in between these two numbers. I'm looking at row 6. It's between those two numbers. So for the homework, the answer to the homework is that it's in between 8 and 10%. That's all they want you to know. And I'll just show you. We just said it's between 8 and 10%. And if I do that, it was just so you know, it was 8.559. That's in between 8 and 10. In Excel, you could do it for real by building this formula. But again, for the homework, you don't need to do anything about this Excel stuff. All you have to do is figure out which factor you need to make these two numbers the same, and then look up in the table to see what it's between 8 and 10, or between 12 and 14, or whatever. You just got to figure out what it's in between, and that's as far as you have to go. Hopefully that all makes sense. I have 2 more videos just to help with specific homework problems. There's one homework problem where they're asking you to do a refurbishment. And if you get to that homework problem and get stuck, go to that video. It's right after, it's probably the 3rd video. And then finally, when you get to the practice exam, which might not be for a week now, but when you get to the practice exam, there's a ski resort problem. And if you get to a ski resort problem and you're really confused, there's a whole video that demonstrates that. Hopefully all of this is helpful.